Hello everyone, a great geometry question today. We need to find the area of this blue triangle. We know each of the side lengths right here, square root of 3 the first side, square root of 10 the second side, and the third side, square root of 7. And a lot of students might be saying, hey mister, we can easily do this. We know a lot of formulas. For example, this formula, the area of a triangle equal to 1/2 a times the height to this side. But in our case, we don't have any height right here. If we look closely, we don't have any height. We only know the side length. So it's not a good formula in terms of our question. Another formula, for example, if you look closely, we need to know the angle between of these sides. In our case, we don't know any angle, we don't have any angle right here, we know only each of the side lengths, so it's not a good formula in our case. The third formula, a lot of students say, okay, the third formula, the Heron's formula, we need to know the semi-perimeter, and we need to plug in each of the sides into this spot. But if you look closely, for example, let's look closely to our semi-perimeter right here. If we add all of this is a really complicated expression, and imagine you plug in these square roots right here into these spots instead of a, b, and c, so it will be like a really difficult question for you to solve this, to simplify this square root. So it's great approach, but it's not the great approach in terms of time, because you need a lot of time to simplify this expression. So we need to find the better way. How can we do this? And right now I'm going to show you this really great trick. I think everyone should know about this Pythagorean theorem. Every student in the school should know about this theorem. This theorem will help us a lot in terms of geometry. So it helps us to find the missing side lengths of a right triangle. So this is our sides a and b, and c is our hypotenuse. So it states that a squared plus b squared equal to c squared. We have three side lengths, so let's plug in right here. Let's plug in into this formula. Let's plug in our side lengths. So square root of 3 we plug in right here, square root of 7 plug in instead of b, and square root of 10 we plug in instead of c. Right now, let's remember a little bit about algebra. We can easily cancel these square roots right here and this square right here. We can also do this in these cases with this square root and with this square and with this square root and with this square. So as a result, we have really interesting expression. Right here we have 3, right here we have 7, right here we have 10. If we add it, we have 3 plus 7 equal to 10. So as a result, Pythagorean theorem works in our case. So it implies that our triangle has the right angle right here. So this is a right triangle, which helps us a lot, because right now we can easily find the area of this right triangle. This is our formula, a times b divided by 2, so we don't need our hypotenuse right here, we need only side lengths, a times b over 2. Let's plug in this sides into these spots. So let's plug in square root of 3 square root of 7 right here, and if we divide all of this by 2, we have square root of 21. According to square root properties right here, we can easily write it as square root of 3 times 7, and as a result, if we find an approximately value to our challenge, this is 2.29 square unit. So I hope you understand this explanation. Really great challenge. You can also solve it with a Heron's formula, but it's not that good in terms of time, because you need maybe 2 times more time to solve this challenge. But if you look that this triangle is a right angle, it helps you a lot. So thank you for your time. I hope you understand this explanation. Definitely don't feel bad if you got this wrong. See you in the next videos. Have a great day.